All right, hello everybody. So I wanted to talk about writing the equations of lines, which just builds on what we've learned about finding the slope between points and using slope to understand how steep the line is and if it's going up and to the right or down and to the right. So slope, or the textbook uses the word gradient, is just the direction that the line is pointing in. Now, if I want to find an equation for a line, an equation is a really specific connection between the x and the y values. It tells you exactly how to get one of those letters if you know the other letter. And so when you think about an equation, if I just draw a line, what I want an equation that describes exactly the points that are on that line. And a line has two different things that are important about it. It has a direction that it's moving in, but it also has a specific location that it's sitting at. So, for example, the red line that I just drew and this purple line right here have the same direction, they have the same slope, but they're at different locations. So you need to know both of those things in order to write the equation of the line. So what I'm going to do is just use any point. This looks like, let's find a nice looking point on the line. How about this point right here? This point right here looks like it has an x value of -5 and a y value of 1 because each of the boxes counts for half a unit. So I'm just using that as a point. And then if I try to find the slope of the line, I'm just going to see how many boxes up and over it counts. So I'm going to connect from here to another point there, and I can count up and over. Let's see how many boxes up and over we're going. 1, 2, 3, 4, 5. So a rise of 5 and a run of 1, 2, 3, 4, 5, 6. Run of 6 right there. And so that means that I know that my slope for the line is 5 over 6. Now here's the crucial idea about a line. If you connect any 2 points on that line, it's going to have the same ratio of rise over run. Meaning if I draw a big triangle like this, connecting my two random points on the line, it's going to also reduce down to 5 over 6. It might be 10 over 12, but that's really the same thing. It might be 2.5 over 3. It might be some crazy decimal over some crazy decimal, but any 2 points on the line will always have a 5 over 6 slope. And so I'm going to use that idea, and I'm going to use this as my fixed point right here. And what I'm going to do is I'm going to create another random point. I'm putting it here just for illustration purposes, but what I want you to imagine is that this random point could be right here, or it could maybe be over there, or it could maybe be way the heck down there. I'm using the letters X and Y to say that it's a random point that could live anywhere along the red line. The fixed point is going to be called X1 and Y1. When we put the little subscript on it, we're telling you this is a specific fixed point. It does not move. So these are not letters that vary. These are letters that are fixed. And the X and the Y in my random point, those are allowed to slide anywhere up and down the red line. And so what I just explained is that any 2 points on the line are going to have a 5 over 6 slope. And we know how to find the slope. We do the subtraction of our y values, that's our rise, and we do subtraction of our x values, that's our run. So I can write here y minus y1, which is our 1 value, over x minus x1, which is our -5. And so what that reduces down to is saying, I'm going to draw a little arrow instead. 5 over 6 is equal to y minus 1 over x plus 5. A lot of times, it's nice to get rid of the fraction, so multiplying both sides by the bottom of the fraction. The fraction I'm talking about is this on the right side here. So that would mean 5 over 6 multiplied by x plus 5 equals y minus 1. I'm going to see how close we got Obviously, I just kind of drew this freehand, so I don't think it's going to be perfect. But if I type 5 over 6 times x plus 5 equals y minus 1, you can see that that red line is almost perfectly aligned with what I had drawn. The only difference is my hand-drawn line isn't perfect, but dang, that's pretty close. So that's the idea of point slope form. I want to explain also why it's useful, and then make sure that you see what the general version of the equation looks like. So the reason that point slope form is useful is because it tells you exactly how to figure out one of the letters if you know one of the other letters. So let's say for some reason you care about the line when x is equal to, let's just say when x is equal to 1. Maybe you're just really curious, what is the height of the line when x is equal to 1? So what I can do is take x equal to 1 and replace the letter x in the equation with the number 1. Copy everything else down, and then just use my algebra skills to figure out what the y value is. So I do my parentheses first, then I do 5/6 times 6, so that's 5, and then I add 1. And so the equation tells me now that the y value has to be 6 when x is equal to 1. This is saying that 1 comma 6 is on the line. The equation lets you calculate what points are on the line. All you have to do is make up a number for one of the letters and use the equation to get the corresponding other letter. Okay, so that's the purpose of equations. And so I've just done an example of point slope form and showed you a little bit of why it is useful. The general formula is just that y minus y1 is equal to m times x minus x1. The letter m is your slope, or if you're in England, it's your gradient. And the letter y1 and x1 come from your fixed point, which really can be any point on the line. Every point is equally important. No point is more important than any other point. So that's it for point slope form for now. In another video, we'll talk about how we can switch between the different forms of the equations and do some more examples. So please comment, ask questions if there's anything that I could do to help.